Dr. Marty here. We are now moving on to our review of Unit 4, which is on functions. And before we get to talking about functions, I think it's important to start by discussing what a relation is. A relation. So we're going to talk about relations here to get started. So first of all, what is a relation? Well, for your definition of relation, a relation is a set of pairs of input and output values. Okay? A relation is a set of pairs of input and output values. And when we talk about relations, we're thinking about some set of pairs of values. Okay, so what does that mean? Well, let me give you an example. Okay, let me give you a specific example of a relation. Okay, so here we have a set of pairs of values that looks like this. 5, 2 is the first one. 7, 3 is the second one. 4, -1 is the third one. Okay, so those are a set of pairs of values. There's an x value and a y value. X is 5, y is 2. X is 7, y is 3. X is 4, y is -1. Okay, so they're a pair of values where there's an input and an output. All right, here's another example. We could have input, or x, output, or y. Okay, so all I'm doing is representing these numbers in a table. Inputs 5, outputs 2. Input 7, outputs 3. Inputs 4, outputs -1. Okay? So this helps us understand that a relation is just a set of pairs of input values, those are the x values, and output values, the y values. Okay? So what are some characteristics of relations? Well, there are multiple ways to represent a relation. And I'm going to talk about a few of those. First, be ordered pairs. Right? This over here, 5, 2, 7, 3, 4, 1, those are just ordered pairs, right? You learned that last year, or maybe even the year before. Okay? That is one way you can represent a relation or a set of pairs of values. Another way would be an input-output table. That's what we have below that. Input-output table. Right? You learned that a table looks like this. You have your inputs on the left, outputs on the right. Okay? You could also represent that as points on a coordinate plane. Right? If you graphed those points on a coordinate plane, that would be a way to represent a relation. Or you could have what's called a mapping diagram. We're going to see a mapping diagram in one of our next sections. Okay? So characteristics of a relation. Remember, a relation is a set of pairs of input and output values. Example would look like this. They can be represented as ordered pairs, input-output table, points on a coordinate plane, or a mapping diagram. And then finally, what are some non-examples? What are some examples of numbers that are not relations? Well, what if we just had 4? That's a constant, right? 4 is just a constant number. It's not a set of pairs of input and output values, right? How about a variable like x? It's a variable, right? No relation here. There's no input-output there, okay? What if we had 7x? Well, that's an expression. Expression is not a relation. A relation is a set of pairs of input and output values. You have some that go in and you have something that comes out as a result. Okay? So we're going to start with that. And next up, I'm going to show you how to visualize a relation as an input-output table, mapping diagram, ordered pairs, or coordinate plane. Okay, so you should have a set of notes that looks like this. We're going to cut these out Okay, and I'm going to show you how to do that. I'm going to cut along the lines on the outside. Hopefully you're doing this as you're watching. And obviously, if you've already done this, you can fast forward through the video. Okay, so we have now something that looks like this. Yeah, and what we have to do is we have to be very careful, and we have to cut. What we're going to do is we're going to fold this in like this. We're going to fold this one in like this, making kind of like a little book. Then we're just going to cut down this line just to the fold. Okay, just down this line, the fold. There we go. Okay, so we know what a relation is. Let's investigate those ways to represent a relation. We've got ordered pairs, we've got coordinate plane, we've got input-output table, and we've got a mapping diagram. So I'm going to start with ordered pairs. Okay, start with ordered pairs, and I'm going to use red for this one. So if I flip this up, ordered pairs, that would look like something like this. This is a symbol for a set. We have 4, 2, 3, -1, 5, 7, right? End of set. Whoops, put a little bit of an extra squiggle in there, sorry. Okay, so that is a set of ordered pairs. Let's look at an input-output table, right? Input-output table can look like something like this. It's going to be input, and output. Now, the input is the x value. It's also called the domain. The output is the y value. It's also called the range. Okay, so we might input 4. Our output would be 2. Input 3, output 1. Input 2, output 7. Input -3, output -8. This is a table that shows the values that go in and what comes out as a result of the x value. The y is a result of the x. Okay? So we can compare that to ordered pairs, and we can see that similar, right? Ordered pairs has an x and a y value. Input-output table has an x and a y value. It's just different ways of representing. Now, these aren't the same values, obviously. Let's go down here and look at a coordinate plane. Okay? Now, when I talk about a coordinate plane, I'm essentially talking about a graph, right? So a coordinate plane would look something like this, right? We'd have a graph. Okay? And you might have a point here, like -2, 1. Might have a point here, 2, 2, right? This is over 2, up 2. Might have a point here, 1, -3. Right, so this is graph on a coordinate plane. Okay, so we had ordered pairs. These are just the ordered pairs graphed. You can see I actually wrote the ordered pairs on there. Here's an input-output table. Finally, let's look at a mapping diagram. Now, this is the one that you haven't seen, and I referenced it on the previous page. Mapping diagram is kind of an interesting looking thing. Okay. In a mapping diagram, you only write each number twice. Okay. So I'm going to put an asterisk. Only write each number once. Not twice, once. You only write each number once. Sorry, it's been a long day. So, if I had a set that looked like this, right? 1, 2, 1, 3, 4, 3, 6, 7. Okay, I'm going to have a little spot over here for the inputs, or x, right? And what are our inputs? Well, 1 and 1, 4 and 6. So I'm only going to write each number once, so I only write the 1 once, 4, 6. Okay? That's this side of the mapping diagram. Now we have y, or our outputs. What do we have? 2, 3, 3, 7. So 2, 3, 7. Now, here's where it gets interesting. What you need to do is you need to draw an arrow connecting every x to every y. So 1 goes to 2, so I'm going to draw an arrow here. 1 also goes to 3, I'm going to draw an arrow here. 4 goes to 3, I'm going to draw an arrow here. 6 goes to 7, I'm going to draw an arrow here. Okay? So basically, you have an arrow going from each x value, each input, to its corresponding y value. So when you look at these, if you look at all 4 of these, ordered pairs, input-output table, it's clear that what we're describing is a relation where we have a set of ordered pairs. There's an x and a y, x, 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 y, right? Those are relations. Now, why are we learning this? Because we're going to talk about functions next. And functions are actually a type of relation. And they're an important type of relation that we need to know a lot about in algebra. So I'll be back next time with some information about functions.